Hello everyone. Today we are going to see walk, trail and path for a given graph. Now if we have graph G with n vertices and n edges, then walk is alternating sequence of vertices and edges of given graph beginning and ending with vertex such that every edge is incident on a vertex which precedes and succeeds that edges. Now if we take walk, this is here. If we have to travel from vertex 1 to vertex 3 here, by how many ways we can travel here? Yes, now we can go from vertex 1 to 3 by this way here. This is from vertex 1 to this is 5, 4 and 3. So this is we have to call simply as a walk. If we have to write this is as a W1, so we will write this walk as a from vertex 1 to then this edge F, then this 5 vertex, then we have this edge here, then again this vertex 4, then this edge here H and this vertex 3. So this is the walk here, right? So what we have done here, we have created one alternating sequence of edges and vertices here. Now another way we can travel from vertex 1 to 3 here. Yes, we can travel from this edge 1 to 4, then this here 4 to 2, then by this loop again by traveling this. Yes, this is also we can write as a walk. So we will write here this one, then edge, then next again this vertex 4, then this edge D, again this vertex 2, again this loop here. By traveling this loop again we will have this vertex 2 here, then again this edge C, and this is here ending vertex, this is 3. So this is walk, right? Now we can check here, this walk we can also write in the form of only vertex here. So we can write this walk as a 1, 5, then 4 and this is 3. That means yes, so this alternating sequence we can also show by this here, because this 1, 5 vertex 1, 5 represent this edge here. So we will follow this notation. Okay, now here we have to find another walk from vertex 1 to 3. Yes, so what is here? Yes, we can travel from this 1 to 5, then again this 4, again we can travel to vertex 1, then again this 2, 4 and 3. So we can write here this is 1, then this last one is here vertex 3. Okay, so this is another way we can travel from vertex 1 to 3. So this is here simply the walk. Now we can check that here we can repeat number of edges and vertex. That means in a walk edges and vertex can be repeated more than once, right? Yes, in walk edges and vertex may be repeated more than once. So here yes we can check that here we have traveled from this vertex in last, this is walk, we have traveled from this way to this here. So we have repeated this vertex 1 here, right? Next we can check that here this vertex 1 and 3, these are the terminal vertices. Now again if we have to find another walk from vertex 1 to 4, by how many ways we can travel from vertex 1 to 4? Yes, we have here this from vertex 1, then by this edge F, then this vertex 5, then G edge, then this is 4. Again, yes, 1 F by this F, then we can end at this vertex 1. So we have this is close walk. Say why we have to call this is close walk, because here terminal vertices are same here. So next, so we have close walk and open walk. If terminal vertices are same, we have to call this as a close walk. If terminal vertices are different, then that walk is we have to call as open walk. So next we have here length of walk. So number of edges in the walk including repetition is called the length of the walk. Now yes, in this walk W4 here, what is the length of this W4? Length of this walk W4, how many edges we have here? This is 2 here. Similarly, this length of this W5. So what is here? How many edges included in this walk? So here we have 3 edges. So length of W5 is 3. Similarly, we can find length of all this walk. Yes. So number of edges in the walk including repetition of the edges is called the length of the walk. Now next we have trail. So what is trail? A walk in which no edge is repeated is called a trail. Yes, a walk. What is trail? It is a walk in which no edge is repeated. Yes. So we can see that here W4, W5, these are the trail here. Yes, now we can check also that whether this is trail or not here. What we have to check, in this walk there should be no repetition of edge. We can repeat vertex but we can't repeat edge here. Yes. So next here we have path. So what is path? It is open walk in which no vertex and no edge is repeated. It's called path in graph G. Right. So what is here? A open walk in which no vertex and no edge is repeated. So here we can say that this here when we have traveled from vertex 1 to 3 without repetition of edges and vertex. So that walk is called path. So we have to denote path by letter P. So if we have to travel from vertex 1 to 3. So yes, so this is by how many ways we can go here? Yes, so we can travel from vertex 1, then this edge E, then this vertex 4, then this H edge and this vertex 3. So this is the path. Similarly, if we have to find P2, second path, if we have to travel from vertex 1 to 3, so yes, we can travel from this edge F, G and H. So this is also next path. 1, then edge F, then vertex 5, then G, then vertex 4, then H, and this is here ending vertex 3. So path is an open walk. That means this is also the walk. But here restriction is that we don't have to repeat any edge and any vertex. So this is the path. Similarly, length of this path is what? Length of this path, what is here? Number of edges including in this path. And this length of this P2 here, how many edges included here? We have 3 edges. So this is length of this path here. So next, if we travel from vertex 1 to 4, okay, let if we write that is as a walk, consider this is our 6th, consider that is our walk. If we travel from vertex 1 to 4 by this way, this is from vertex 1 to 2, then this loop and then this by HD to vertex 4. So we will write here this walk here 1 to edge A, then vertex 2, then B edge, that is loop, then again to vertex 2, then by this HD we travel to vertex 4. Now we can check that here by this loop we have repetition in this walk. This vertex 2 is repeated here. So this walk is not a path here. This is not a path, right? Why this is not path here? Because in this walk we have repetition of vertex. So we can say that in path, loop cannot be included. Yes, so loop cannot be included in path, right? Thus we can say that walk, trail and path, it's a way by which we can travel from one vertex to other vertex. So this is, we have seen walk, trail and path. So yes, we have to remember that walk, trail and path, these are the alternating sequence of edges and vertex. Only difference is that in walk there is no restriction on vertices and edges. That means we can repeat vertices and edges. And here in trail there is restriction on edges. That means we can repeat only vertices. We can't repeat edges. And in path there is restriction on both vertices and edges. That means we can't repeat vertices and edges. So this is the difference between walk, trail and path. Thus we have to remember that walk, trail and path is alternating sequence of edges and vertices. In walk we can repeat vertices and edges more than once. In trail we can't repeat edge, we can repeat vertices, and in path we can't repeat vertices and edges. So this is all about vertices and edges. Thank you.